Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and hello everyone. So today we're going to have a look at radio wave based imaging technique. So what is radio wave based imaging technique actually is? Radio wave based imaging refers to technique that use radio wave frequency, the lower spectrum below visible light, to create images of objects, structures or tissues. Instead of using visible light like cameras, these systems rely on how radio waves interact with matter through reflection, absorption, scattering, or resonance. So, how does it work? Briefly, it's about the transmitter sends out waves and tracks how they interact with objects, specifically through reflection, absorption, scattering, or resonance, as I mentioned before. To help you understand this, we can put it like this. Imagine you're holding a flashlight, you turn it on, it shines the light, it hits the object, and the reflection helps you see what's around it. Well, same like radio waves based imaging, but instead of visible light, we use radio waves. As we can see here, it starts with the transmission. First, the system sends out radio waves like throwing a signal into the environment. These waves travel through air, ground, or even the human body. After that, the interaction. As the waves move, they interact with different materials. Some waves pass through, some get absorbed, and some bounce back depending on what they hit, just like how light reflects through glass, metal, or water. Next, the detection. Here, sensors pick up the returning signal. These echoes carry information on what the waves encountered. Lastly, the image formation. Here, computers process those signals and turn them into image. What was visible to our eye, like underground pipes, brain tissues, or objects under clothing, suddenly becomes visible. Well, that is how basically a radio waves based imaging technique works. So, in this presentation, we will dive deep in how a ground-penetrating radar, GPR, medical scanning, MRI, and security scanning millimeter wave scanner works. Enjoy!
Now we will moving on to our evaluation. Radio wave-based imaging offers two profound physical advantages. First, it emits non-ionizing radiation. Because it operates at ultra-low frequencies, it carries zero risk of structural or DNA damage, which means it is perfectly safe for continuous human exposures in medicine or security. Second, its long wavelengths allow for deep material penetration. These waves means easily bypass surface obstacles, such as it is passing directly through dense media like dry soil, concrete, or clothing to reveal hidden hazards that standard optical cameras simply cannot see. And of course, these benefits comes with its limitation. The first primary disadvantages is the diffraction limits. Because radio waves have much longer wavelengths than light, they restrict spatial resolution, which means it is impossible to capture extremely fine structural details. And also we have high signal attenuation, which means materials with high moisture content or conductive metals will rapidly absorb and scatter the wave energy. This will restrict the imaging performance in damp environments or wet tissues.
Hello, I am Hamadi and I will be explaining about the basic concept of radio wave imaging. Radio wave imaging works by sending a low frequency of electromagnetic wave through a target, and any altercation done to the wave, we can find out the information from there. We can use a computer to translate the changes made to the radio wave that has bounced back to calculate certain values and display it into a screen. One of the things that use radio wave imaging are MRI and radar. MRI stands for magnetic resonance imaging, and in simple terms, basically atoms produces faint radio wave which can be collected by a computer and a receiver and then can be translated into an image and information. For radar utilizes a focused pulse of radio wave aimed towards a target. Now the wave would then get bounced back into the receiver and the computer would then calculate it just like any other tool and the computer would then calculate the distance by calculating the time taken for the radio wave to bounce back, and also the frequency shift to calculate the speed of the target. Now, another tool that uses radio wave-based imaging is a ground-penetrating radar. It is mainly used to inspect or search for something underground. The GPR can use to give us a rough idea, or at least give us a little information about the environment or the situation underground without having to dig the soil and the earth and having to ruin the terrain. The GPR sends a continuous stream of ultra-high frequency wave so that it can see constant change and see very detailed images can be presented into the monitor. It works almost similar to other radio wave based tool. Basically, when the radio hits an object, a portion of the wave would then bounce back, and we can use that to determine the type of object. The time taken, just like the radar, the time taken by the radio wave travel when it was produced and when it received the radio wave can determine the depth of the object, and the radio wave, based on how much has been reflected, can be used to determine the type of object that we have located. And here is some examples and practical use for a ground penetrating radar, where I can use it for utility mapping for construction, so we can check any gas line underneath a PVC water pipe that we afraid might hit when we dig into the concrete. We can use it for forensic and archaeology to detect some compacted stone foundation for buildings underground that has been buried over time. We can also use it for glacier thickness measurement to determine how stable a ground is in icy places like in Antarctica. It detects the bedrock and it measures how thick it is.
So now let's take a look at magnetic resonance imaging, or we call it as MRI. It is a medical instrument that used to look deep inside the human body, to produce a high quality 3D image with zero harmful radiation. How it works? It is all start with a powerful superconducting magnet that creates a strong magnetic field, aligning the hydrogen proton inside the body water molecule in all the same direction. Next, the machine fires up a pulse of radio frequency wave into the body, temporarily knocking these protons out alignment. When the radio pulse is turned off, the protons snap back into alignment with the magnetic field and emit their own faint radio signals, or we call echoes. So, because the different tissues have different amounts of water, the proton realign at different speed. A computer then maps the variation into a detailed 3D image. The action is allowing the doctors to safely see what hidden beneath the surface of human body. Next is millimeter wave scanner. Millimeter wave scanner is a whole body security screening device that most commonly spotted at airport security checkpoint. This technology is specifically designed to detect concealed objects hidden underneath clothing using ultra low power radio waves that are entirely safe for humans. So, inside the machine, there are two rotating antennas emit a specific band of high-frequency radio wave, typically ranging between 30 GHz and 300 GHz. Because these millimeter waves can easily pass right through lightweight clothing material, but it cannot penetrate human skin or denser object, they bounce right back. The scanner sensor then capture this reflected wave to instantly construct a detailed 3D image, and then immediately highlighting any hidden items without compromising passenger safety.
Now we will compare the three radio wave based imaging techniques. For the first technique is ground penetrating radar. It is used to detect radio wave reflected from objects below the ground. It is mainly used to locate underground pipe, cable, and structure. Second technique is MRI. It is used to detect radio frequency signal from hydrogen nuclei inside a strong magnetic field. It is mainly used to produce detailed image of internal organ and soft tissue. Lastly, the millimeter wave scanner. It used to detect wave reflected from the body and hidden object. It is commonly used for security screening, especially at airport. It is commonly used for radio wave-based imaging allow us to see object and structure that cannot be seen directly. Ground penetration radar is used to detect object underground. MRI produce detailed image inside the human body, and millimeter wave scanner help detect hidden objects during security checks. Although these technologies have some limitations such as high cost and signal interference, they are very useful in medicine, construction, archaeology, and security. Overall, radio wave-based imaging has made detection and examination safer, faster, and more efficient.